Okay, so let's put what we just talked about into practice. So in this case, let's assume that every dot on the string on the screen represent a student in the class. And then you see that, again, there's two different types of colors. There's gray, there's dark green, so maybe that's two groups. But it's still not very quickly. I mean, it's not so quickly we can depict this. If we change to a different color, it's easier, right? It's better contrast, but still, we can do better than this. So now we could do sorting. By sorting, I mean we could group. We can put all the blue dots into one area. We sort them, and then we move all the green dots together. So it's much easier to see the two groups, right? And similarly, we can do grouping, right? I would group the blue dots and the green dots. I will also use proximity, right? So the blue dots are close together. They're also well aligned, so that form a nice group. Same for the green dots. And the other thing we could do is we could put grids. We can put grid lines that will further help us to differentiate or delineate these groups. And I can also do this without the grid lines. Okay, so let's assume that for now, the green dots represent, let's say, undergraduate students, and the blue dots represent graduate students. So far I have, the undergrad and the grads. But what if I wanted to represent people or students who live, where do they live? Some of them live on campus, some of them live off campus. But how do I represent that information in this visualization? Well, one thing I could do, as we're shown here, is I can use two boxes, right? So let's say that the box on the left represent all the students who live off campus, whereas the box on the right represent all the students who live on campus. So that's one way I can represent this new variable, which is where do they live. Now let's make this even more interesting. Let's say that the red dots represent students who are transfer students, who transfer somewhere else from some other school. Right? And again, you see that in this visualization, I can represent the type of students as well as where do they live. Let's take another example. Again, let's say every dot on this visualization represents a student. In this case, I'm using shapes to represent different types of students. So in this case, let's say the dots represent graduate students, and the stars represent undergraduate students. So clearly, they're both grad and undergrad students. Now, in addition to shapes, let's say I also want to use colors as a way to represent a variable. So in this case, let's assume that the green color represents all the students who came from the I school, right? So they could be undergrad or grad students from the I school. The blue color, the blue dots, represent all the students from the computer science department. And the red colored objects, stars or circles, represent students from, let's say, the art school, right? So we have students from three majors or three departments or schools. Now I want to represent students in three different classes, and I'm using a box to represent a particular class, right? So now I have 3 classes with students from undergrads or grads from one of the 3 or the 3 schools or majors. One thing I can do is I can sort the students by the colors, or in other words, which school they come from, right? Well, actually, in this case, I'm sorting by the shapes, right? It's first it's the stars and then it's the circles. I'm sorting by the shapes. So in other words, I'm sorting by undergrads or grads. So as you can see here, the first box, we have a lot more graduate students than undergraduate students. So maybe that means, okay, so these undergrads represented by the stars must be very good, right? There are very few of them in this class where most of the students are graduate students. Similarly, I could also sort the students in a class based on the color of the objects, or in other words, which school they come from. And you can see that here, the class in the middle, I have a pretty even mix of students from the 3 departments of the schools. So what does that mean? That means maybe this is a good place to recruit for a new interdisciplinary program, right? Like computational art or something. Okay, so we've just worked with the visual encodings, which means how do you map information or variables in your dataset to a particular visual property or attribute. We've talked about pre-attentive attributes, things like length or position, where we can quickly perceive them. We've also looked at color, position, and proximity. Proximity will help us group things. We've looked at grids, which also helped us group things. We've looked at sorting. We've also looked at visual representation of multivariate data, meaning that the data set have many variables, and we map each of the variable to a particular visual property. Okay, on to the fourth, our last concept I want to talk about. So one thing I want you to take away from this class is that good or effective information visualization is more than making pretty pictures, right? It should tell us a good story. And here I'm giving you one example. This is information visualization created by the Facebook Data Science Group, where they try to visualize Facebook friendships and where they live. In order to tell a story, we need to ask good questions that guide our inquiry. And we really need to know our data, because otherwise we can't really create meaningful visualization. And again, the end goal is to tell a good story that you can engage your viewers of your visualizations, answer the questions, satisfy their curiosity. If you want to know more about this particular example, just Google Facebook friendship visualization, and you will find a few more details about this visualization. Okay, what do you need to succeed in this class? Or what would you need to ultimately be able to create appealing and effective information visualization? I believe there are a few things you will need. You need curiosity, you need independence, you need to take initiative, and you need to be patient. Not only all of these, you should also be willing to work with 3 kind of things. Right? You need to code, you need to write programs to create visualization. You need to have a good sense of design. And later in the course, we'll talk about some design principles. And finally, you need to be comfortable working with data, because visualization is based on the data we have. And here I'm showing you a picture of acrobat training in China, where I believe they really need to have curiosity, independence, initiative, and patience. This is a good example, analogy. So if we do a good job in this course, what you will be able to do? Well, you will be able to identify and define user needs related to visual representation. You will be able to ask good questions. You would also be able to interpret or analyze the meanings of data visualizations and information graphics, right? And third, and perhaps most importantly, you will be able to design and create your own meaningful data visualizations. And last but not least, you will be able to understand many of the ethical and social issues or implications related to visualization of data.